All right, so we're going to jump ahead to chapter 11. So we're going to be talking today about permutations and combinations. So we're going to be starting in on our probability section. So one of the things that we want to talk about, though, is this fundamental theorem of counting, fundamental counting principle. So if I want to know how many possible outcomes there are, what I'm going to do is I'm going to look at the different combinations. So if I had 5 shirts, 3 ties, and 4 pairs of pants, if I want to know how many different outfits there are, what I'm going to do is I'm going to actually multiply these together. 5 times 3 times 4, and I'm going to get 60 here. And so there are 60 different outfits. So this is the counting principle here, and it's just taking the different pieces. So we're going to end up multiplying those together. If we were going to draw that out into a pattern, what we could do is we would have 5 shirts. Okay, so these are the shirts. And then we'd have 3 ties. And then off of each of these, we would have 4 branches. 1, 2, 3, 4. 1, 2, 3, 4. It's going to get kind of messy. And then you can kind of see here that we would just add those all together. Recording? All right. And so then we would keep putting up the 4 pieces here. And then it gets kind of messy with this tree diagram. And what you do is then count up all these pieces, and you'd find that you'd have 60 there. So that's the diagram form of it. So that's the counting principle. Most of you are pretty familiar with that, so I just wanted to kind of touch base with that. And what we're going to talk about is factorials next. So this is called a factorial. And what a factorial does is it takes the number and then multiplies it by each preceding number. So this is actually n times n minus 1 times n minus 2, all the way down to 5 times 4 times 3 times 2 times 1. Okay? So if I have 7 factorial, I would then go 7 times 6 times 5 times 4 times 3 times 2 times 1. And I'd multiply these all out. So just so you know, 0 factorial by definition is 1. Okay? Because that's very important that we understand that. Now, this factorial button is actually on your calculator. So if you come in on your calculator here, what you're going to do is there's a PRB button right down here. So you're going to hit the PRB button, and you'll see an NCR, an NCR, and then a factorial, an exclamation mark. So you can just arrow over to that and click on it. And that's your actual factorial. So the key, though, is you have to make sure you put the number in first. So if I wanted to have 7 factorial, I'd go 7 PRB, which stands for probability, hit the the factorial, and so then I'd hit enter, and I would get 5,040. So we need to make sure we understand on this how to work factorials. So the next part where we're going to talk about now is permutations and combinations. So there's 2 formulas there's a permutation formula and a combination formula. So the permutation formula, order matters. So this is like looking at the Olympics and wanting to know the possible outcomes for first, second, and third, because it matters who's first, who's second, and who's third. So when we're looking at that, we want to understand that order matters. So we have NPR. So N stands for the total number of participants, or the number you're choosing from. P stands for permutation. R stands for the number that you're selecting or you're choosing. Okay? So this is total number. This is number selecting. Okay? And so I would have n factorial over n minus r factorial. So if we were looking at a race, and let's say we're looking at a race and we have 8 participants, and we want to know how many different combinations, how many different order there is for first, second, and third. First through third placement. Okay? And so what I'd have here is I'd have 8p3, and so this would be 8 factorial over 8 minus 3 factorial. Now, I'm going to kind of show you the algebra behind it, so that way we can see it, and then I'm going to show you how to do it on your calculator, because it's considerably quicker. So if you remember, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? And here I have 8 minus 3, which is 5. So 8 minus 3 gives me 5, so that gives me 5 factorial, which is 5 times 4 times 3 times 2 times 1. So when I look at this, this permutation ends up, these whole pieces cancel out. So I end up with 8 times 7 times 6. And so if I look at that, that gives me 336 different ways. So if I wanted to know in a race with 8 people, how many different ways first, second, and third could come in, there's 336 different ways to do that. Now, if I was going to do that same thing on my calculator, what I'm going to do is I'm going to come in and I'm going to type in my 8 first. So I'm going to put in 8 first, and then I'm going to go to my PRB button. I'm going to type in PRB, and then you notice there's an NPR, NCR, and factorial. So I'm going to choose the NPR by hitting the enter, and then I'm going to pick how many people I'm choosing, which is 3. So I'm going to hit 3, and then I'm going to hit enter again, and it gives me the 336. It's very nice that you can kind of use the calculator to get it really quick. So that's permutations. Order matters in permutations. We have to know if it matters who's first, second, or third. Okay? So this would also be a thing where if we wanted to select a class, who would be president, vice president, secretary, treasurer, the order that those people are voted in and selected matters. So we'd use a permutation. So in a combination, order doesn't matter. So we don't care if it's first, second, or third. So if we're looking here, this might be like a committee. So it doesn't matter in a committee if you're selected first or last, you're still part of the committee. So just like a permutation, so we have n, which is the total number. We have r, which is how many we're selecting. So we have NCR. So that becomes n factorial divided by the product of r factorial and n minus r factorial. So if we were kind of looking back at our participation here, maybe I don't want to know who finishes first, second, and third, but let's say the top 3 move to the next race. Now I have changed this problem from being order matters to order doesn't matter, because I don't really care if a person ends up being first, second, or third. We just need to know how many different combinations of people can move on. And so now we've changed this to be a combination instead. So this becomes 8 factorial over 3 factorial and 8 minus 3 factorial. So combinations are going to have a fewer number on average than the permutation. There are a couple of times where they're going to be the same, but most of the time it's going to be a smaller number. So this becomes 8 factorial over 3 factorial and 5 factorial. Now if I come back up here, I have my 8 times 7 times 6 times 5 factorial, and I have 3 factorial times 5 factorial. Well, the 5 factorials cancel out, leaving me with 8 times 7 times 6 over 3 times 2 times 1. Well, 3 times 2 is 6, so these cancel out. So I'm left with 56. So if I wanted to know how many different combinations of 3 people move on to the next race, it's 56. The key to permutations and combinations is to understanding order. So I'm going to look at the combination here. I'm going to show you how to do it on the calculator. So once again, we have to type in our total number. So I'm going to go 8. I'm going to hit the PRB button. And now I'm going to go over to the NCR button. I'm going to hit enter. I'm going to type in 3, enter, and I end up with the same answer of 56. Understanding when order matters and when order doesn't matter is the key to permutations and combinations. So we're going to kind of talk about just kind of an example of one where we would have to look at whether it matters or doesn't matter. A chemistry teacher divides his class into eight groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. In how many different ways can he select the drawings? Now, does order matter there? Does order matter if you're selected first or fourth? Are you still getting your drawings selected? The answer is order does not matter. So we're going to look at that. There are 8 people, so there's 8 drawings. I'm going to choose 4 of them, and so we have 8 combinations of 4. So we have 8 factorial over 4 factorial and 8 minus 4 factorial. And so we're going to use our calculator on this one. So I'm going to go 8 probability NCR 4, and I get an answer of 70. So there's 70 different combinations. So that's the big thing with permutations and combinations. Make sure you recognize whether order matters or not, and then you can use the appropriate formula.